Bismillahirrahmanirrahim. I welcome you all again in the course of engineering dynamics. This is lecture number 11, and I hope all of them are fine and enjoying the best of health. Today, I will solve one of the solved problems, and then some 4 to 5 are the unsolved problem regarding the r theta coordinates or polar coordinates. So dear students, let's move to the sample problem 2-10, the 7th edition of JL Mariam. Our tracking radar lies in the vertical plane of the path of a rocket, which is coasting in upward flight above the atmosphere. For the instant when theta is equal to 60 degree, the tracking data give r is equal to 25 exponent 4 feet and r dot is equal to 4000 feet per second. And theta dot is equal to 0.8 degree per second. The acceleration of the rocket is due only to gravitational acceleration, and for its particular altitude is 31.4 feet per second square. So the acceleration acting on it is the only, that is the acceleration due to gravity. It is given at that altitude is about 31.4 feet per second square, vertically down. For these conditions, you have to find out the velocity of the rocket and the value r double dot theta double dot. So this is the tracking radar, and this is the missile, and it's trying to track that particular missile, and this is the line of sight of the radar, which I take the radial direction, and perpendicular to this is the theta direction. So we are given the radius, we are given the angle, we are given the theta dot, the variation, the angular velocity. This per degree per second, we can convert it to radian per second, and we are given the value of g is only the acceleration, which should be in the downward direction. So this is the acceleration in the downward direction. One component will be along the theta and one component along the r. So let's see, it's very clear from here, because it is given that r dot is VR is equal to 4000 feet per second, and V theta is equal to R theta dot. We are also given the value of theta dot is R times the 0.80 is the degree per second. Therefore, I take pi by 180 and we get 3490 feet per second. The velocity is very simple, VR square plus V theta square under root. We find out the velocity of the missile, which is 5310 feet per second. As total acceleration of the rocket is g is equal to 31.4. If you see, this is the acceleration, right? And so therefore one component of this g is along the theta and one component is along the radial direction. So therefore, what is the angle? Angle, of course, this angle is 30 degree. So this angle is 30 degree. So therefore, this radial component in the negative direction, it is g of cos of theta, and this one is the g of sine of theta, which is the, so AR is minus 31.4, cos of 30 is minus 27.2 feet per second square. Similarly, theta is 31.4, sine of 30 15.7 feet per second square. So AR is equal to R double dot minus R theta dot square. I have the value of now AR, and I have the value of R and theta double dot. I can theta dot, I can find the value of R double dot, which comes to be 21.5 feet per second square. Similarly, a theta is equal to R theta double dot plus 2R dot theta dot. I know the value of a theta, R dot, theta dot, and R, and by putting the values here, right, the only thing the important is the theta dot is basically in radian per second. We are given in degree per second, we multiply with pi by 180, and the theta double dot is minus 3.84 exponent minus 4 radian per second square. So this is the velocity component. You see, this is the radial component of the velocity, and this one is the theta component of the velocity. It is in the positive direction, both of them. And this is the, I've shown you the g is downward. This is the theta component, which is basically a times g times cos of theta. This is g minus g times sine of theta. Thank you. So let's move to the unsolved problems in your book. So the problem 2-31. The position of the slider P in the rotating slotted arm OA is controlled by a power screw as shown. At the instant represented, theta dot is equal to 8 radian per second, theta double dot is equal to minus 20 radian per second square. Also at this same instant, R is equal to 200 millimeter. We have given the radius as 200 millimeter, r dot is minus 300 millimeter per second, r double dot is 0. For the instant, determine the r and theta components of the acceleration of p. So this arm is moving in the angular direction, and this p, which this particle or this slider is moving along the radial direction when the lead screw is moving. We need to find the r and theta component of the acceleration. As we know that theta dot is equal to 8 radian per second, theta double dot is minus 20 radian per second square. It is given to you, right? It is given to you. So therefore r is equal to 200 millimeter, r dot is minus 300 millimeter per second, r double dot is 0, which is given. We need to find ar and a theta. As we know that v is equal to r dot er plus r theta dot e theta, and the acceleration is r double dot minus r theta dot square er plus r theta double dot plus 2r dot theta dot e theta that we have derived in the previous lecture. So here vr is equal to r dot, so vr is minus 300 millimeter per second, and v theta is equal to r theta dot 200 into 8, 600 millimeter per second. So we can find the velocity very easily. It is minus 300 er plus 1600 e theta millimeter per second. ar is equal to r double dot minus r theta dot square. R double dot is 0. We know the value of r and theta dot. We put the value, we get minus 12800 millimeter per second square. Similarly, a theta is r theta double dot plus 2r dot theta dot 200 into minus 20 which is given, and this one is 2 times r dot is equal to minus 300 into 8 becomes minus 8800 millimeter per second. So a is equal to minus 12800 er minus 8800 e theta millimeter per second square, or minus 12.8 in the radial direction, minus 8.8 e theta in the theta direction and meter per second square. So it's very simple question. We have given the values. We just put the values into the formulae intelligently, and we find the acceleration and again the velocity. Now let's move to little difficult problem. A car P travels along a straight line, right? This car is moving along the straight line with a constant speed of 65 miles per hour. At the instant when the angle is 60 degree, determine the value of r dot in the feet per second and theta dot in degree per second. This height is given to the 100 feet, and this is the reference point O from where you are tracking your car. At that particular instant, the height is 100 feet, and of course the velocity of the car in this direction is 65 miles per hour, and this angle is 60 degree. So we have to find out the acceleration. Means through the acceleration we find out the r dot and theta dot, and of course we will take this one along the radius in the radial direction, and then the downward will be the theta is the theta direction. So if you see this one I have made, this is my radial direction and this is my velocity component in the theta direction. Of course this r direction, this theta direction I have taken the upward direction. So therefore this is if I have taken this theta in the upward direction, so therefore this is the radial component and this is the theta component. So the radial component is positive and theta component is negative. This angle is 60, so this angle is also 60. First of all, I convert this velocity in miles per second into the feet per second. It is 65 exponent 3 given to you, 3.28. Basically I converted into the 65,000, 3.28, sorry, multiply by 1.6 also, sorry. So 1 is 65 into 1.6 exponent 3, because 1 mile is equal to 1.6 kilometers and 1 meter is equal to 3.28 feet divided by 3600, you will get 94.75 feet per second. So next we move to sine of 60. I need to find r. Sine of 60 is equal to 100 by r is equal to 115.5 feet. So nothing is now very difficult, because we know this angle is again 60 degree. So Vr is equal to V cos of theta. We get 47.3 feet per second, and V theta is equal to Vr is equal to r dot also. So we also can find out the r dot, which is one of the requirement here. So V theta is equal to r theta dot, which is equal to V sine of theta in this case. So we know the value of r, we can find the value of theta dot, which is equal to 0.704 radian per second. If you want to find in the question in the degree per second, multiply by 180 by pi to convert 1 radian into degree. This is 40.7 degree per second. Next problem is regarding the robotic arm, which is basically sliding hydraulically. As the hydraulic cylinder rotates around O, this is rotating around O in this direction, like here, right? The exposed length L of the piston rod P is controlled by the action of oil pressure in the cylinder. So if the cylinder rotates at a constant rate of theta dot 60 degree per second and L is decreasing at the constant rate of 150 millimeter per second, it is decreasing down, it is coming inward. So it becomes negative. Calculate the magnitude of the velocity V and acceleration A of the end B when L is equal to 125 millimeter. This length is fixed and this length is changing with time. So we have a theta dot. Theta dot is given to you 60 degree per second. So 60 into pi by 180 is pi by 3 radian per second. If I need to find the length is equal to minus 150 millimeter per second, which is going to be changed, right? The length which is fixed, we will add it when we take the value of r. We need to find velocity and acceleration where L is equal to 125 millimeter, please. So this is the L dot. This is L dot 150 millimeter per second. So we know that V is equal to R dot ER plus R theta dot E theta. So VR is simple, minus 150 exponent 3, which is minus 0.15 meter per second, which is R dot or L dot, which is the rate of change of the distance. V theta is equal to R theta dot. Here when we take here R 375 plus 125 exponent minus 3 to convert it to meters, and this is theta dot pi by 3. We get the value of the theta, which is 0.5236 meters per second. And the question is to find the velocity. So it's minus 0.15 is the radial component, 0.5236 is the theta component, and we take the square and taking the root, we get 0.544 meter per second, or 554 millimeter per second is the velocity of the arm, which is which is the total velocity having the radial component. In the radial direction, it is decreasing at 150 millimeter per second, and in theta direction is it is basically increase. It is the in the positive theta direction 0.5236 of 523.6 millimeter per second. So we need to find the acceleration now. The acceleration, we know that it's a radial component, it's the theta component. We have already discussed in R double dot and theta double dot 0, because R dot is about 150 second derivative 0, theta double dot is given to you 0. So AR is equal to, we have only minus R theta dot square. We know the value of R, we know the value of theta dot. We put this, we get minus 0.548 meter per second squared. It is in the opposite direction, in the radial direction. And A theta, of course, it is again theta double dot is 0, it's 2R dot theta dot. I put the value, I get minus 0.314 meter per second square. And then taking the square of the radial component, theta component, and taking the under root, we get 0.631. It is meters per second square, or 631.6 millimeter per second square. Next problem is problem 2-141, which I selected for you. The slider P can be moved inward by means of the string S. While the slotted arm rotates about point O, the angular position of the arm is given by theta is equal to 0.8 t minus t square by 20, where theta is in radians and t is in seconds. The slider is at 1.6 meter from when t is equal to 0, and thereafter it is drawn inward at the constant rate of 0.2 meter per second. Determine the magnitude and direction of and expressed by the angle alpha relative to the x-axis of the velocity and acceleration of the slider when t is equal to 4 seconds. So this is the mechanism actually. This is the x and y. This is angle theta. The slider is moving, and this arm is moving in the angular direction. And this P, which is slider, is basically connected with a rope, and this is moving. So therefore, this rope is winding up on this pulley, and therefore the position of the P is changing along the radial direction. I think the question is clear. Now we move to the solution. We have given theta is equal to 0.8 t minus t square by 20. So we have r 0.16 meter, and at t is equal to 0. We have given r dot is 0.2 meter per second. We find the velocity acceleration at t is equal to 4 seconds. So we have the r is changing. R is changing at 1.6 minus 0.2 t, right? 1.6 minus 0.2 t. This is the, says it is changing a 0.2 or 0.2 t. 1.6 it was, and now it is changing with time is 0.2 t. So what is V? V is equal to R dot ER plus R theta dot E theta, and similarly the acceleration R double dot minus R theta square radial component R theta double dot plus 2R dot theta dot is the theta component. So take the first derivative of theta, which is called 0.8 minus t by 10, and I take theta double dot minus 1 by 10 radian per second square. What else we required? We required r. We have the value of r. How I write the value of r? This is the important thing, which is maybe confusing. The slider is at t is equal to 0 is 0.6, and thereafter it says drawn inward at the constant rate of 0.2. So 0.2 meters per second. So it is 1.6 plus 0.2 times of t, right? So therefore, because it is moving inward, so I take the negative sign. So it is 1.6 at t is equal to 0, and it is moving inward, it's 0.2 t. So that is basically minus 0.2 t. Therefore, this is the relationship for the radial movement. Now take the derivative of r dot. We get the value of r dot 0.2 meter per second, and of course we put the value of t is equal to 4. We get 0.8, and of course r double dot is 0. So v is equal to r dot, which is minus 0.2 er. Then it is r theta dot square. So r theta dot 0.8 minus 4 by 10, because t is equal to 4 seconds. I can find the value of v is equal to 0.2 er minus and 0.32 e theta, which v is equal to 0.38. Angle, of course, I find out is tangent inverse. E theta by er is 38 degree with the x-axis. AR is equal to r double dot minus r theta dot square. So therefore this is 0. R double dot is 0 minus r is 0.8, theta dot is 0.4. I get minus 0.128 meter per second square. A theta is equal to, of course, r theta double dot. So I put the r theta dot plus 2 r dot theta dot is minus 0.24 meter per second square. The acceleration is minus 0.128 er is minus 0.24 e theta. So A is equal to 0.272 meter per second square, and theta both are negative. So I take the tangent theta is 0.128 by 0.124, because this is, if I say this is the r and this is theta, right? So r is also negative and theta is also negative. So therefore this when I take the angle, this should be er by e theta is 180, whatever this angle is, because it is in the second quadrant, is minus 28.07, right? So you get an angle of about 152 degrees for the x-axis. Let's see the next problem. The piston of the hydraulic cylinder gives pin A a constant velocity v 3 feet per second in the direction shown for an interval of its motion for the instant when theta is equal to 60 degree. Determine the theta r dot double dot theta dot and theta double dot, where r is equal to OA. This is ROA, the velocity in this direction. So when we take, of course, this is radial direction and this is theta direction. So this height is 6 inches, which is given to us. With the help of this, we can find the value of r that particular instant. So v is equal to 3 feet per second, theta is equal to 60 degree, r double dot theta double dot is unknown, OA is r. If you see, this is the radial component, this is theta component, this is the velocity given to you. I use sine 60 is equal to 0.6 over r. Sorry, it's 0.5. So 6 inches or 0.5 feet. So I get 0.577 feet. So VR is very simple. It is minus of a cos of 60, right? This is the velocity, and this is the angle. So this angle is theta. So this velocity has a component of cos, which is along this minus 1.5 feet per second, and theta is the positive direction, 3 sine of 60, 2.6 feet per second. We know that is a v is equal to r dot er. So vr is r dot, right? So r dot is 1.5 feet per second, and r theta dot is 2.6. So theta dot is 4.5 feet per second. The two requirements have been met. Now we take the accelerations, r double dot minus r theta dot square, and then er plus theta double dot plus 2r dot theta dot is theta. AR is 0. There is no radial direction, no radial acceleration. Therefore, r double dot minus r theta dot square is equal to 0. I find the value r double dot from here is 11.68 meter per second. Similarly, this acceleration is also 0. So this theta double dot becomes minus 2r dot theta dot r. We get 23.4 meter per second square. The question is from where I find out the radial the accelerations are 0, because it says the pin A is the constant velocity, so therefore the accelerations are 0. So from here I find I double dot, theta double dot, R dot, and theta dot. Let's move to next problem, 2-143. The rocket is fired vertically and tracked by the radar station shown. When theta reaches 60 degree, other corresponding measurements give the value of R is 30,000 feet, R double dot 70 feet per second square, theta dot is 0.02 radian per second. Calculate the magnitude, the velocity and acceleration of the rocket at this position. So this radar is tracking the rocket, and rocket is moving in the vertically upward direction. Please understand this question, because theta is 60 degree, R is 30,000 feet, R double dot is given to you, R dot is given to you. Let's take first of all the velocity. This is the radial direction, this is the theta direction, and this is the direction of the velocity. At this instant, the R is this. Similarly, this is the acceleration, and this is the radial component of the acceleration. So R dot ER plus R theta dot ER. So R dot is 0. Right, R dot is 0 because there is no change in velocity. R is fixed, so therefore VR is equal to 0, and V theta is equal to R theta dot, which is 30,000 times the theta dot, which is given to 0.02, is 600 feet per second. Similarly, R double dot minus R theta dot square ER plus R theta double dot plus 2 R dot theta E theta. So as theta double dot is also theta dot is there, theta double dot is 0, R dot is 0, this component goes to 0. So therefore I have also only show you the radial acceleration. So AR is 70 minus the R double dot given to you. R is 30,000.02 whole square, that is about 58 feet per second, right, feet per second square, and A theta is 0. So AR is equal to AR is equal to A sine of 60, because we need total acceleration. So A sine of 60, so it is A is equal to AR by sine of 60, because this AR sine of 60, right, we get 67 feet per second square. Again, V theta is equal to V cos of theta. So we have V is equal to V theta by cos of 30, and total velocity is 1200 feet per second, because this velocity is the theta component. So V is equal to V cos of theta, as per this is given. V, this angle is this, so VR, this one, take it, right, this one, this angle is 60, so VR is equal to V cos of theta. V theta is equal to V cos of theta, because this angle is if I say if I say this angle is this angle is 60 degree, right, this angle is 60 degree. So therefore this component, in this case theta component, so V theta is equal to V cos of theta. So therefore we get the value of the total velocity in this vertical direction. Problem 2-145, a jet plane flying at a constant speed of V at an altitude of h is equal to 10 km is being tracked by radar located at O directly below the line of the flight. If the angle theta is decreasing at a rate of 0.02 radians per second, where theta is equal to 60 degree, determine the value of R double dot at this instant and the magnitude of the velocity V of the plane. So we are tracking this plane from this radar, and this is moving in the horizontal direction with velocity V, this radius R and H. So this height is 10 km, right? Theta dot is 0.02 radian per second given to you. Theta is 60 degree, R double dot is unknown, V is unknown. So VR is equal to V cos of theta, right? This is VR, V, this is VR. So this should be V cos of theta, which is V theta is equal to, of course, the negative direction, because I take theta in this direction, positive. So this is minus V sine of theta. So sine of if I take sine of 60 to find the value of R is perpendicular upon hypotenuse, I get the value of R 11,547 meters. Next we have V sin theta is equal to R theta dot. So R dot is 0. So V is equal to R theta dot of sine of 60, which is 267 meter per second or 360 km per hour. Similarly, if AR is equal to 0, there is no radial acceleration. R double dot minus R theta dot square is 0. So R double dot is equal to R theta dot square. We get R double dot 4.62 meter per second square. These are the two requirements which we have find out. The question is why I taken the radial component of the acceleration is 0, because it is moving with the constant radial constant velocity of in the radial direction. So therefore the radial acceleration is 0. Now let's see another question which I selected for you. the particle P moves along the parabolic surface shown when x is equal to 0.2 meter, right? When x is equal to 0.2 meter, the particle speed is v, which is 5 meter per second. For this instant, determine the corresponding values of r dot, theta dot, both x and y are in meters. And remember that we have given the curvature of the parabolic surface is phi is equal to 4x square. So x, this is the radial component, and this is the theta coordinate system. So this angle is actually theta. So we have given the x, we have given the v, we need to find r dot, theta dot. As y is equal to 4x square, right? So we are given x is equal to 0.2, we get y is equal to 0.16, and from taking x square plus y square under root, we get the value of r. And similarly, we can find the angle is tan inverse vy y component over x component 38.67 degree. Okay, let's we take the derivative. The derivative of this means slope at that particular point, dy by dx is equal to 8x, which is equal to 1.6, and if you take theta dash, it is basically 58 degree. Okay, because alpha is equal to, because we need to find the angle with the x-axis, because alpha is equal to 58 degree, because please remember that this is the tangent, we have find out this angle. So this 58 degree minus 38 point this, we get this angle which is being required, 19.32. Now the radial component of this velocity is 5 cos of 19.8. 5 cos, we need this one, right? 5 cos of 19.32 is 4.7 meter per second. P theta is equal to 5 sine of 19.32 is 1.654 meter per second. Therefore, theta dot can be found out by r theta dot. So we have the value of phi theta 1.654 divided by r. So we get the value of 6.46 radian per second. So confusing is this angle is, we have find out 38.67. From the angle at that particular slope, or taking the slope, it gives me the angle is about 58 degree. 58 degree. So this angle is 58 degree. This angle from this axis, x-axis, this theta is 38.67. So this difference of the angle is given to you. So you need to find, you have this component. This we need to find. We have the velocity in this direction. So we take this component, and of course this component will give the radial and tangential. I hope you understand. So okay, students, we have completed this curvilinear motion, r theta coordinates. Up till now, we have discussed the curvilinear motion along the planar motion, means 2D. And next, inshallah, we will discuss, the next lecture will be the curvilinear motion in the cylindrical coordinates. Because when you have r and theta, and also the height is changing, so we have to have consider cylindrical coordinates. And I hope you will understand what I have discussed in this lecture. And please go through this again and again. You will get most of it. Thank you.